We're going to continue our study of vectors by talking now about linear combinations. Linear combinations we're going to be working with for a while, and it is essentially a vector that is created by combining other vectors and their scalars. So all the C's that you see are scalars and all the V's are vectors, and you might see this with A's instead of C's or X's instead of V's, and it's all of the same thing. So it makes much more sense if we can look at this in a visual aspect. So as you can see, I already have a graph out here for you, and I've already plotted V1 at 1, 5, and I haven't actually drawn the vector, I just plotted the point. And then I went ahead and also multiplied it by 2, so that's 2v1. I multiplied it by -1 and multiplied it by -2. And then I did the same for v2 at -3, 4, and then 2 of them, -1 of them, -2 of them. And then as you can see, I just took my ruler and drew in essentially a grid that connected all of the v1s and then that same line through -1 v2 and -2 v2, etc. So you can see exactly what I've done here. And here's why I did that, because I want us to have a good visual of what I'm talking about when I talk about a linear combination. A linear combination says that I need a scalar times a vector plus a scalar times a vector plus a scalar times a vector as many times as I need to generate a new vector. So let's look at vector u. And again, I've plotted the point u, but vector u would be this line that looks just like that. Now, we know from the parallelogram rule that u would be the opposite corner of a parallelogram. So it's very straightforward for me to draw a parallelogram that looks just like this. And I can see, based on that black parallelogram that I've just drawn, that I've got 2 v1s and -1 v2. And so that's how I'm going to draw or write vector u. So vector u is generated by taking 2 v1s plus -1 v2. So I'm going to write minus because it's the same. And that is what vector u would be, is 2 v1s minus v2. Let's do the same for w, keeping in mind that w is going to be more difficult. So w means that here's my vector, and as you can see, if I try to draw in a parallelogram, I probably should have chosen a color different than black, but we get the idea, that I've done a very poor job with this second parallelogram because w is not the opposite diagonal corner of 0, 0. It's just sort of floating in the middle. So let's take a look at how we might fix that instead. I'll use blue. Nope, I'll use green because I need it to be different than blue. So it looks like I can go ahead and follow this line. And it's going to stop about right here. And I need W to be the opposite corner, which means it's going to look something like this. Now, what does that mean? That means I'm just going to have to do some serious estimating. It appears that this might be about 1 2/3, or 5/3, we'll call it. So vector W is generated by using 5/3 of V2. And how many V1s? Well, it looks as though it might be 1/4 of V1. So 1/4 of V1. So that is how I would write vector W would be 1/4 V1 plus 5/3 V2. And again, that's just an estimation because we're not given anything clear. We've just estimated that W is about 1/4 of V1 and 5/3 of V2. This is a similar question, but it doesn't really look similar because it's harder. It's harder in two ways. First of all, I can't just draw a picture and connect the dots. So boo, now I have to do actual work. And two, I actually have 3 values in my column vector instead of just 2. So now we're in R3 instead of R2, which of course would make drawing a picture much harder. And believe me, you don't want to see me try to draw a picture in 3 dimensions. So let's go ahead and stick with just the math here. First thing I want you to understand is, what is the question asking? It's essentially asking the same thing that our last question asked. It's saying, if I've got V1 and if I have V2, can I draw some sort of linear combination that ends up at 7, 4, -3? So in our last examples, we just drew a picture. Now we have to do math to get us there. So essentially they're saying, is there some C1 that I can take times V1 and some C2 that I can take times V2 to end up at B? That's the question that they're asking. So let's expand on that. Is there a C1 that I can take times 1, -2, -5? And is there a C2 that I can take times 2, 5, 6? That's going to end up at 7, 4, -3. Now, if I wanted to, because I know that C1 is a scalar and C2 is a scalar, I could think of this as C1, -2C1, -5C1, plus 2C2, 5C2, 6C2, equals 7, 4, -3. Now keep in mind that this is just a system of equations, and I could write it as C1 plus 2C2 equals 7, and -2C1, etc., and I'm not going to do that. And the reason I bring that up is because I know a system of equations can be written as an augmented matrix, so I'm just going to skip that step and go straight to 1, 2, 7, -2, 5, 4, -5, 6, -3. And now I have an augmented matrix. And I know exactly what to do with an augmented matrix. All I have to do is do all of my magic row operations to end up at reduced row echelon form, and that's going to help me to solve this question. So I've just rewritten the matrix, and I've got what looks like a nice pivot there of 1. And I'm going to make everything below that a 0. So I'm going to take 2 row 1 plus row 2 to be my new row 2. And I'm going to take 5 row 1 plus row 3 to be my new row 3. Whoops. To be my new row 3. So that ends up at 1, 2, 7, 0, 9, 18, and 0, 16, 32. Now I want that 9 to be a pivot, so I want it to be a 1. So I'm going to take 1/9 of row 2 to be my new row 2, and that's all I'm going to do in that step. And again, you should be good at row operations by now, so I apologize if I'm going too fast through that, but I don't want to make a 39-minute video. I just want to make it as short as I can. So now I have my pivot here of 1, my pivot here of 1. I want the values above and below that 1 to be a 0. So I'm going to take -2 times row 2 plus row 1 to be my new row 1, so that this 2 can become a 0. And I'm going to take -16 row 2 plus row 3 to be my new row 3. So that's going to give me this guy in the middle, exactly the same as before. My new row 1 is 1, 0, 3, and my new row 3 is 0, 0, 0. And I'm fine with that, and here's why. keep in mind that this guy is V1 and this guy is V2 and this guy was B, but essentially what that tells me is what values I'm going to use for C1 and C2, because this row says 1C1 equals 3. Now again, where did I get that? From right here. I've taken C1 times that V1. So that's what I've done here is I've got 1 C1 is equal to 3, and I've got 1 C2 is equal to 2. So the question is, can it be written as a linear combination of V1 and V2? Yes. What are the weights? The weights are C1 is 3, so I could say 3 times 1, negative 2, negative 5, plus 2 times 2, 5, 6 is equal to 7, 4, negative 3. And again, you can very quickly do that mental math in your head to do the check. 3 times 1 is 3, 2 times 2 is 4, yes, that equals 7. 3 times negative 2 is negative 6, plus 2 times 5 is 10, negative 6 plus 10 does equal 4. And then 3 times negative 5 is negative 15, plus 2 times 6 is 12, negative 15 plus 12 is negative 3. Check, check, it all works out. So again, we've answered this question. We had to do a little bit more work because we couldn't draw a picture, but we were able to answer that question and find the weights of 3 and 2. So just to drive that point home, or maybe beat a dead horse, one or the other, just to clarify, a vector equation, which is our vectors multiplied by some scalar, the sum of all of those vectors multiplied by their scalars, has the same solution set as a linear system whose augmented matrix is A1, A2, A3, etc. So that is what I tried to make clear on our last example, where I first wrote it as a vector equation and then magically turned it into an augmented matrix and solved that augmented matrix, and then magically turned it back into a vector equation so I could see what those scalars were. So I just want you to be very clear about the relationship between those things. They're different representations of the exact same thing. I also want to talk about something new, which is a span. So if I have all of these vectors that are in Rn, then the set of linear combinations is denoted span v1, v2, v3, etc., and is called the subset of Rn spanned. Now, you don't see subset of Rn spanned very often, but you do see span quite often. And span essentially is just the collection of all of the solutions to those linear combinations. So it's all of the scalars combined with all of those vectors that are solutions. Now that we know what a span is, let's take a look at this question. It says, is B in the plane created by the span A1, A2? And then it gives us A1, A2, and B. And so this looks like a question that we haven't done before, and yet this is exactly a question that we've done before. Not the same values, but essentially what this is saying is there some C1 that I can take times this matrix, this vector, and is there some other scalar that I can take times this vector that gives me B? And this should look really familiar because we just did a question exactly like this. And so I'm not going to go through writing this as a system and then turning it into an augmented matrix. We're just going to go straight to the augmented matrix. I'm going to say 1, 5, negative 3, negative 2, negative 13, 8, 3, negative 3, 1. And I'm going to try to get this into reduced row echelon form. So let's start by, I've got my pivot of 1 there. Let's make everything below it a 0. So 2 row 1 plus row 2 is my new row 2. And negative 3 row 1 plus row 3 is my new row 3. So row 1 is going to remain the same, 1, 5, negative 3. Row 2, I'm going to end up with 0, negative 3, 2. And row 3 is going to be 0, negative 18, 10. Now from here, keep in mind that I want this guy to be a pivot, so I can either divide everything by negative 3, or I can work on getting zeros above and below that. So let's start by just getting a 0 below that. So if I take negative 6 times row 2 and add it to row 3, then I'll get a new row 3 where I've got a 0 where I want it. So this is still going to be 1, 5, negative 3, and this is still going to be 0, negative 3, 2, and this is going to be 0 and 0, and I get negative 12 plus 10, which is negative 2. And here's where we have an issue, because remember what this is saying is that 0 equals negative 2, which of course is not ever going to be the case. So this essentially tells us that this vector equation has no solution, or that B is not in the span A1, A2. So it says, is B in the plane created by span? And that is, of course, the answer is no. Here's a practice for you, and this is an application question, obviously. I haven't already put this into the vector equation for you, so I'm actually asking you to write the vector equation first, and then use that to write the augmented matrix and solve. So if you would, press pause, read through the question, and then solve. So again, what we're being asked to do here is we have two mines, and we're saying, how many days should I operate mine 1, where I have 20 metric tons of copper and 550 kilograms of silver every day? And how many days should I operate mine 2, that has 30 metric tons of copper and 500 kilograms of silver every day, so that I end up with 150 tons of copper and 2,825 kilograms of silver? This is the question being asked. Now, how do I solve this? Hopefully we're very comfortable with this at this point. I'm going to turn this into an augmented matrix, and I'm going to use my row operations. Oops, yep, that's right, 500, 28, 25, and I'm going to solve it. So for the sake of time, I'm going to use this notation. Now this notation just means that the matrices are equivalent, so I'm not going to show you each row operation this time, but I am going to show you the results after each row operation. So obviously on the first one, I want to make that 20 into a 1, so I'm taking everything in the first row by 1/20th, which gives me 1, 1.5, 7.5. And row 2, I haven't done anything to yet. And now that 1 is a pivot, I need to make 550 into a 0. And so what I'm going to do is take negative 550 times 1, or times row 1, and add it to row 2 to get my new row 2. So, oops, this is still 1, 1.5, 7.5. And this guy is now 0, negative 325, and negative 1300. And again, that's negative 550 times row 1 plus row 2. So row 1's looking kind of good, but row 2's not quite there yet. Row 1's going to remain the same, and I'm going to take everything in row 2 times negative 1 over 325, which gives me 0 here, 1 here, and 4 here. And so now I've got this pivot right where I want it, but above that I want it to be a 0. So I'm going to take negative 1.5 times row 2 and add it to row 1, giving me 1, 0, 1.5, and 0, 1, 4. So the question says, how many days should we operate each mine so that we have the correct amount of copper and silver? And my answer is right here. So I would operate mine 1, 1.5 days, and mine 2, 4 days in order to have the required amount of copper and silver. Here's another practice that I haven't gone through with you. We've done a similar question in a previous video, but essentially I'm asking a similar question to what you've just done, but I'm asking for what value of h, for what value or values of h is b in the span of A1 and A2. So we see this word again, span, which of course means that I'm going to be able to write this as an augmented matrix. And the question is, can I find the value for h to make this work? So I'm going to leave you there for just a moment. If you would press pause, go ahead and see if you can finish this question and answer for what value or values of h would b be in the span. If you're totally stumped, you can just wait for me to go through it. Otherwise, I would like you to try it on your own. When you're ready, press play to see how you did. So again, I'm going to use this abbreviated notation and just tell you what the row operations are. My first row is going to remain exactly the same. My second row, I'm going to take negative 4 times row 1 plus row 2, so that's going to give me a 0 here. It's going to give me a 5 here, and it's going to give me a negative 15 here. And I also want a 0 where my negative 2 is, so I'm going to take 2 times row 1 plus row 3, which gives me 0, 3, and 8 plus h. So far, so good. Now, of course, that 1 was my pivot. I want to make this 5 a pivot, so I'm going to take just a fifth of row 2, and that's the only thing I'm going to do on this step. So that's 0, 1, negative 3. And this guy remains the same. Now, because this and this is a pivot, I want everything below 1 to be a 0. So I'm going to take negative 3 times row 2 to be, and add it to row 3. So that's going to give me the same row 1. Row 2 is going to remain the same as well. And I'm taking negative 3 times row 2 to add it to row 3. So that gives me 0 here, and that gives me 0 here. And again, I'm taking negative 3 times 3, negative 3, which is 9, plus 8, which is 17 plus h. Now, here's the problem. The only way that this works is if 0 equals 0 on this last row. Because if h was some value that made it not 0, then this would not be valid. So essentially what I'm saying is 17 plus h must be equal to 0. So h must be equal to negative 17. So the question is, what value or values of h? And h must be negative 17 for b to be in the span of A1, A2. So that is the solution, is yes, it works, but only if h is negative 17.